Attack on Titan. One of my favorite mangas and animes, and one of the most pop culture influencing animes that has ever come out of Japan. With its darker stories, haunting themes, and also real life kind of morals, it is an interesting story to read, but definitely not for the squeamish or, the faint of heart. The anime is coming to a close, and it's going to be a very sad thing for most people. Now, if you don't know what Attack on Titan is, essentially it is a post-apocalyptic story of humanity where humanity has been brought to the brink of extinction and has resurrected walls to basically prevent itself from being absolutely destroyed from the man-eating humanoid creatures called Titans, which have mysterious origins. Obviously, humanity creates a bunch of tech to prevent themselves from being eaten by Titans and to kill said Titans. So with the anime coming to a close, I wanted to do some sort of engineering DIY project to kind of honor the anime finishing, and on top of that, honor one of my favorite mangas and animes. I love doing engineering projects, so this was going to be awesome. Now, I've done some searching on Google and on YouTube, and it's a funny thing. Not a lot of people have really decided to do the most infamous and most well-known tech from Attack on Titan. Not the Thunder Spears, not the swords. It's the ODM gear, or the omnidirectional mobility gear. In the manga and the anime, this gear allows human beings to slay Titans by being able to move in all directions, and even mimic flight. Well, I did some Google searches, and there have been some people who have attempted to make the ODM gear into reality. Some better than others, but honestly, no one has really come close to it. Some people made like kind of a toy-ish version of ODM gear that really wasn't ODM gear. Some people made this chunky, huge version of it, which doesn't look functional really at all. But, it's still impressive nonetheless. But I feel like we can take a step further to making ODM gear in real life. If you want to see those videos, I did have a link down below, or I have a couple of links down below for everyone to kind of check on those videos, like Tyler Arovera, Just Dustin, and a bunch of other people. Some of them are Japanese links, so they will be a little confusing for people who don't speak Japanese. But that being said, this video is the story of how I made the world's first functional ODM gear. Well, so let's do. All right, let's get this started. So in the show, ODM gear means omnidirectional mobility. So basically it means that the user of the ODM gear can move in any direction he or she wants. Basically moving on whatever plane they want. If you didn't fail geometry in high school, if you remember, there are 3 kinds of planes, at least when it comes to geometry. You have the Y plane, you have the X plane, and you have the Z plane. Basically, Y plane is forward and backwards, X is left and right, and then Z is up and down. So we need this gear to work in that sort of fashion, something that allows us to move in most directions. Most. Now, obviously, if we look at the show, there's some shots that just aren't physically possible. There's just some things the ODM gear can do that cannot be replicated in real life. I mean, look at this clip of Levi, for crying Brian. The man is literally killing about a dozen people at supersonic speeds. So we can't really do that in real life. So we're gonna have to make the best we can out of that. So we need to divide this into different parts of what the ODM gear really is. As I said, we need to move on all directions. We also need something to go onto our bodies. It's basically a harness that's attached to several mechanics. Awesome. So part 1 is going to be how we're going to deal with the rope system or the winch system, or however we're going to kind of figure that one out. So we have the strings or the rope that will be deployed and then will bring us to our target to the Y and somewhat the X-axis. Then we have the gas. Obviously in the show, it's a fictional ore that's basically native to the actual island itself, but obviously we don't live in a fictional world, but we do have compressed gases. So part 2 will be the gas that will allow us to kind of drift. Now in the show, it allows them kind of to mimic flight, but we can't exactly do that with compressed air. So we're going to make it kind of like a drifting mechanism that allows us to move on the X-axis with a little bit of a drift. And then part 3 is the firing mechanism. Obviously, in the show, it works off probably the same way as a compressed gas for the propelling. So basically, the little grappling hooks are shot at the target via compressed gas, or it could be spring-loaded. One thing that's great about Attack on Titan is that it has great reference points and very much does its research turns to science. Sometimes, most of the time. But, so that's going to be probably the most easy part, is to somehow shoot a grappling hook or a grapple gun, whatever you prefer, at the target, allowing the rope to get to where we want it to go. So part 3 we're going to actually not have in this video because I ran out of time, and it's a simple idea that basically many YouTubers and other engineers have done before. Basically, CO2 compressed gas over a barrel or inside a barrel dart that gets shot kind of like an airsoft gun or a paintball gun, if you've ever seen those kind of how those guns function. I'll explain how they function later as we talk about part 2. But we're going to save the grappling hook part for another time for the upgraded version, hopefully to come. Then we need to think about the different things we need to keep in mind in building this thing. First, we need to keep it light. This thing has to be on our body, so it needs to be at least relatively light. It can't be more than 150 pounds. That's my weight. That would suck. 2, we need a frictionless surface to be able to move from A to B to C. So we have to figure out how to make a frictionless surface or replicate a frictionless surface. Try saying that 10 times fast. And then we have to keep in mind all these different things of strength, and also we need to figure a way to keep this all safe. Strapping things to your body is not the safest thing in the world, so safety has to come in mind. Also, we need this thing to be powerful. This thing needs to be able to move the user with as little stress as possible. Okay, for part 1, the rope system. So to kind of get my brain going, I started thinking about different kind of rope systems. Well, there's such things as pulleys. If you ever had a treehouse growing up, you might know what a pulley is. Essentially, it is a wheel at a fixed point that allows a load to be brought up or move up in the z-axis via having someone pull it or a motor spinning it and basically lifting it off the ground. So we already can see from the system that yes, this can work to move with getting us up and down. Problem is it can't do forward and backwards and not really left and right at all. And we have another problem with this pulley system. The wheel is at a fixed point. This is great for like rock climbing, but the problem is we have to deploy the system to have the wheel either one place. Then we have to have the load, basically also work as the same as having the power to move it. Unless we want to have like some sort of theater trick where someone is on the side basically just pulling us. But that wouldn't be ODM because that's not how it works. So, okay, pulley system doesn't work. Well, okay, how does the show and the manga represent it? Well, again, with the great references from the show and the manga, basically we have these clips and also this reference where basically the rope is basically shot out and then the tension is held and it basically reels itself in on this kind of sewing machine looking spool. Basically this mechanic works very similar to how tape measures work. If you've ever seen a tape measure, which I very much think most people have, tape measure is like this. Basically, you release this piece right here, and then you fix it at one point to hold its strength. Then, when you want to, oh, this is so scary. This is not, everyone hates this part. Basically, when you want to reel it back in, you release, and it comes back in like this. So that's how at least the show represents it. Problem is that this thing can't really move a load forward and backwards. If we think about it like this, we have a 5-pound weight here, and we will extend it first and attach it to the end of this table. Now, if I have this 5-pound weight, essentially I release, it's not moving. Obviously, I can't really it can't really move. Then even without the weight, like, I will lose grip and basically it won't really have anything to pull. So we can't do that. Okay, well, I need some brainstorming. So essentially, I was thinking about things that I'm interested in and things I know about. Well, I like to 4-wheel drive. And if you've been 4-wheel driving, you know that sometimes some people have attached winches to the front of their ATVs or their cars, basically allowing them to get out of trenches, getting out of ditches, and very tough situations. Now we're talking, because winches are very powerful motors that basically allow the user to move forward and backward, and it has a huge power load. Like, these things move cars. So I got this guy. This guy is from Harbor Freight. It is a Battleland 2,000-pound utility trailer winch. Sorry. So essentially, this thing works like so. You have the power connected to it on the 2 poles at the bottom, which thus moves the motor with its controller. The motor moves and then is attached to a gearbox. The gearbox limits the amount of rotations that this thing needs. Then you have the spool, which basically is attached to the steel wire, which is attached to the hook. So this thing can move about 2,000 pounds. So we have the powerful part of it. Problem is that it's not light, it's 15 pounds. So strapping 2 of these guys to myself is about 30 pounds plus. But it's the best solution for right now, at least for the prototype. So we're gonna go with this guy. And what's also great about it is that it has steel wire. In the show, the actual spool or the actual rope/wire is actually iron, which, if you know anything about steel, steel is comprised of some iron and also a bunch of other things like carbon, and depending if it's low carbon or high carbon steel. So that's part 1. Now, we do have a problem though. How do we power this thing? Because this thing's supposed to be on cars. And we can't strap a car battery to me safely, and also we can't really strap a car battery because that won't keep it light. That will literally weigh me down so much. And, as I said, safety. Having a car battery on me works kind of not in my favor. And here's why. If you've ever kind of seen a car battery, you have 2 poles, right? Kind of like just a battery, but they're on the same plane or same kind of surface. Basically, you have the negative charge and the positive charge. If I were to put my hand on both of those while the charge is live, essentially, I become fried chicken like Colonel Sanders. So we don't want that. So that's not quite as safe. And we would have to recharge it after almost every use, because a car battery doesn't have, aside from itself, doesn't have a recurrable charge because it's actually a chemical reaction. So how do we fix this problem? Well, I found this. This guy is a converter. Basically, this takes any outlet, well, most outlets here, at least in the US, and if you want to put it into any other country, you just put a converter on it. Basically, this converts any outlet powers into basically the same output as a car battery, basically around 12 volts. So this guy is a pretty powerful beast. That being said, it is also lighter, smaller, And yes, does have a cord on it, so it's not going to be a cordless system. But again, this is a prototype. We're working with things. And this can safely be housed on the ODM gear. Again, without me having to go like, and basically turn myself into that one character from Home Alone. All right, so we have figured out part 1, which is the rope system. Now we move on to part 2, the compressed gas. So in the show, the gas basically works like this. It originates from an ore that's found on Paladin Island, and then it is basically harvested and created into this compressed gas that basically can propel someone and even mimic flight. We can't mimic flight with compressed gases here in reality, but what we can do, again, is we can make it kind of have a drifting function. And we have tons of compressed gases. I've worked with a lot of compressed gases, like oxygen, propane, nitrogen, and somewhat butane. So this is right up my alley. So I need to think about a compressed gas that can propel us sometimes on the x-axis, sometimes drifting off and basically making a slope. Well, let's think about CO2. CO2 is pretty easy. It's a pretty contained gas that allows for a lot of propulsion. So I started researching things about with CO2. Well, CO2 kind of works like this. So another thing I do is that I like airsoft. And so YouTube, don't demonetize me, even if this gets monetized. But basically, an airsoft gun works like this with CO2. Basically, a CO2 cartridge is placed inside of a gun that basically has this compression chamber. Once this piece is pierced, every time I pull the trigger, I'm releasing the compressed gas, thus propelling the object from the barrel, basically allowing it to go wherever the heck I want it to go. Awesome. Problem is that with this kind of idea, we have to put this in there and pierce it. On top of that, we have this thing shooting something out. We don't have a system where I am both holding this on me and also the projectile. So that's at least it's a starting point, at least. I did some more research. Apparently, there's also this cool thing that if you ever grew up doing Boy Scouts, you know the Pinewood Derby? Yeah, apparently there's a street version of Pinewood Derby that basically straps CO2 canisters to a car and basically sends it completely and utterly flying. How this system works is that they strap a little tiny container, just like this, into a little dock. They press a button, it pierces the container, thus sending the projectile flying. Awesome, okay, closer, we're getting there. Problem, we have to pierce this thing. And I'm pretty sure having a CO2 canister being pierced on me is not a good idea to begin with. And on top of that, we would have to have like 1,000 one of these things pierced all at the same time, because I'm not piercing a giant CO2 canister. Okay. Well, what else can we do? Well, I did more research on what else is CO2. Then I found SodaStream. Basically, if you know how carbonation works, basically when you insert CO2 into water, it makes it bubbly, thus making a carbonation, which is basically how most soda machines work. Awesome. Okay, SodaStream basically has this idea where you have a tiny, well, not tiny, a medium-sized container that is put into the system, and you press the button at will to basically release CO2. Okay, we're getting closer. Problem with this is that this container is so small that this literally can't push anything off the ground or even in any direction. So closer. We're getting there. So then I kind of hit a little bit of a I don't know what to do, because I was like, I can strap a giant CO2 canister to me. However, I would have to create a custom valve, which I would love to do later, where basically the automatic valve basically will be programmed to release whenever I want to based off a program. But this is, again, the prototype, so we don't have the money nor the time to do that. So then I had to go back to the drawing board, and it took me a while to think of something. I remember one night I was just tired, and I was just done. So I went to bed. Guess what I figured out the next morning? the first thing that comes to my mind, WALL-E. If you've ever seen the movie by Pixar named WALL-E, basically there's this scene where you have this tiny little robot that's being propelled in outer space, which has no gravity and no thrust or anything, with a fire extinguisher. Yes, that could work. Obviously, because CO2 sometimes are in fire extinguishers, sometimes it's also dry chemicals. But either way, this still works. It can be a light little fire extinguisher. It could produce enough thrust to move me. A lot of people have made this kind of those kind of videos on YouTube, and we don't have to worry about a compression chamber or a valve or anything like that. It literally is inside the fire extinguisher. So, splendid. Absolutely amazing. So, I went to my local supermarket and got this guy. This guy is a home version of a fire extinguisher, which is small enough for me to put on my person. So from this system, I'm actually going to have it be put on my back. Similar to how the newer ODM kind of works, we're going to have a back plate that is going to attach to this guy, thus having it be able for me to shift and to be able to do some drifting. And what's great, this thing comes with a wall mount. So basically, I don't even have to make anything custom for me to strap it onto my back besides the back plate and the straps. So that alleviates a lot of work for me, and it works. Now, how will I release it, or release the gas, while it's on my back? Now, what I could do is attach a string to it with a motor, and basically program that motor to move it. Also, we could have a servo motor on the bottom of it. Basically, if I can tell the program to do it at a certain angle, or the certain gas at a certain angle to basically have more control, we can make that servo motor move that certain angle. But this is the prototype, so that's going to be a future idea, hopefully. But the system I have now is this. Basically, fire extinguisher. Now we have the nozzle, we have this piece right here with a little tiny hole. The lever will basically be pulled by this steel wire, thus releasing it like so when pulled down. Pretty simple, hopefully will be improved in the future. Okay, now that we have this fire extinguisher idea, we need to do some initial tests to see if it actually can do something. So what I did is that I went to my local park and sectioned off a piece of the sidewalk. I calculated basically the distance from point A to point B. Within that distance, I divided it into 3 segments. Segment 1 was just the push off, just my initial kind of push. My segment 2 would be full throttle on the fire extinguisher, allowing me to have that amount of thrust. And segment 3 obviously would be no thrust, and just allowing the speed to just continue to carry me. Obviously, I need initial push. I'm not going to go over or try to overcome initial friction. So I did the test where I first did a control test where I just did one initial push and then went the entire distance and timed it. Basically also lapping on my phone every time I went to one segment versus the other. Then, the second time, I used the CO2 canister or the gas or the fire extinguisher and went through the entire distance. Obviously, segment 1, no gas. Segment 2, full throttle. Segment 3, just allowing myself to just cruise on down. And according to all my results and all my calculations, using the good old distance, time, and rate equations, I figured out that actually we did gain a lot of time. Now granted, there's some chaos factoring with like some things like wind and there's some things I can't control, but essentially I was able to actually feel like I was being thrusted on this tiny little skateboard. Okay, now that we're done with part 2, and we're gonna skip again part 3 because the grappling hook is pretty easy to do. But I will say this one thing about part 3 is that if you look at paintball guns, which is the idea of having an over the barrel or in the barrel compressed gas launching mechanism, They look super similar to the new ODM Gear. Like, come on, like it's literally a gun that looks like kind of a mini Tommy. It just works so well, and I think it could be an awesome part of the next part of this project. But for this prototype phase of the project, we have all the parts kind of figured out. Now we need to test all of them. So what I did was I made this nice little, what you could say, dummy idea. So as I stated previously, we need a frictionless surface, or at least replicate a frictionless surface. Obviously, I don't want to take ODM Gear on an ice rink. That could cause a lot of issues. So I was thinking we need wheels. Wheels can basically produce a frictionless surface with a good enough of a platform or a surface. So back in my high school days, I was a thespian. So I did a lot of theater. And what I remember from some of it, yes, I know your tricks and your tiny little secrets, theater, is that when you're moving a set, you have caster wheels, basically allowing the set piece to be moved in whatever direction you wanted. So I went to Harbor Freight, got some caster wheel, like dolly furniture thing, and attached a giant piece of plywood, and then attached everything onto it to basically test everything out and see if it was functioning. I attached the winches first on top, then I transitioned to the bottom to just for safety reasons. Not the best idea, just due to the fact of now gravity's pushing down on it, but more on that later. Then I 3D designed and 3D printed a custom holster for the CO2 canister, basically allowing me just to press a lever on the back of the cart. Then there was a little dock for the power bank, and that was it. Now, this infamous little guy was hard because caster wheels like going in every direction, so it was a little hard to maneuver. But because of how hard this thing was to not only make, but also to just work with, I call it the Doom Buggy. Now, if you like Haunted Mansion from Disney parks, you'll know why I call it that. Because this thing was freaking hard to work with, and also could break anyone's shins because of how uncontrolled it was. Yeah, so we're working with it. So then we did a couple of tests, obviously within a contained lab space. Video rolling?
Yep.
Please, for the love. So, editor's note. See that tiny little spark? Yeah, me and my semi-professional cameraman, aka a person I literally just asked off the side of the road to film me. Sounds weirder, I know. Basically, we didn't see this spark until after we filmed. So yeah, we fixed that real quickly and made sure there was no loose wires or connections, because I custom wired this like wench to this converter, because obviously it's not supposed to go together. So we had to custom wire some things with some good old fashioned DIY skills. But basically it was working in the test environment, so we took it out to the roads. Also, editor's note. The context before this scene of this film, it's basically the cameraman and I encountered some people who were asking us what we were doing, and we were talking about Attack on Titan, and this person literally was like, oh yeah, I do watch anime, but you know, it's because I work out. So, yeah.
I just teach here. That's
yeah, but I go to the gym though, so it's like.
So do I. You count me at the
Let's go. Let's go.
bullshit. I mean, I'm moving.
did what I wanted to. Okay, so as you can see, not the fastest thing in the world, mainly just due to the fact that the casters and the amount of weight that this thing is already trying to hold, plus my own weight, it wasn't the fastest thing in the world. And it kept breaking down, just because the spool kept getting caught, because again, as I said, I put it on the underside for safety, but that caused the gravity to basically keep the line with not as much slack as it probably needed. So we fixed that pretty hard, but at least it got fixed and wasn't broken. So with that in mind, we learned a lot from the Doom buggy. In terms of the drifting, in terms of how these winches work, I learned quite a lot. So the next part of it was to start prototyping how to put this on myself. So basically the harness system. Well, we needed also something to house each system safely for my safety and also for the safety of the system in and of itself. So I created these wood boxes that basically housed everything, like the power bank, the winches, and basically almost everything. Then made this back plate that would basically, we would attach the CO2 canister to. And obviously it kind of like looks very much like the ODM gear. From the belt to also having the support straps attached to the boxes, it was starting to come together. So finally, we made the final result. All right, so I have it mainly done. Obviously, we have the attachment on the back with the symbol on it. I'm not attaching the fire extinguisher yet. It will be later. And then we have the control panels here. As you can see, we have both the winches on my side, if hopefully you can see that. And then the battery pack is on the back. So, ooh, this thing is really hard to move. Okay, so yeah, this is the first test wear. It's not super comfortable, but that will make it work. Now that the final design is finally finished, I think it's time for us to do some tests. We're gonna divide this into 3 tests. First, the kill test. The kill test basically works just like in the anime and the manga. Basically, a wooden dummy with this kind of flesh-ish like object that we need to cut at for the nape. Well, that's gonna be pretty easy. Second one is the drift test. Basically, we will have an attach point and allow ourselves to drift just like we did with the Doom buggy, but with the ODM gear, and also see how much speed we can accelerate and if we can make that for a somewhat turn. Then we have the vertical lift test. Obviously in the show, you can see that some of the things where they're suspended from a wall or a building, and basically the winch system or the system in itself holds its weight, basically allowing the person to be just kind of grappled like a rock climber onto this wall. So we need to make the third test, the vertical test. So with that being said, let's get into testing, shall we? Let's gear up. All right, so now we have the first test, the kill test. So just like in Attack on Titan, basically they have these giant like wooden attack titans that they will use to do for training so they can go for the nape of the neck. So we have something similar. We have our good old friend, Timmy the Titan. He's an abnormal, he's short for his size, but he's not compensating. And then we have, of course, the ODM gear right over here. So basically I'm gonna be on roller skates using the ODM gear to get to my target right over there. And we're going to absolutely end him. As you can see, nape of the neck, decimated. Yeah, I'm still on my roller skates with a little walking stick. Not as fast as I would want it, but you know what? It didn't break and it did what I wanted it to. So, success. All right, so now we have the drift test. Just like we did with the Doom buggy, I'm gonna start at one point and then come across here. But the thing is, this is all gas powered. The winch system is not gonna work at all. It's just holding me suspended against this tree. Obviously, we're gonna have the pack on, and that's going to direct me via me pulling a rope to release the dry chemicals. It should be fun. All right, here goes. Stick, case emergency. Oh, I'm going to feed. Oh shit.
Well, that worked. Very well.
Okay, another roller skate report. That definitely, oh, that did something. Not gonna lie, I almost died. Woo! But also gas is everywhere, all the dry chemicals everywhere, and it got my shoes, which were supposed to be out of frame, but that screwed me in the end. Oh well, success! Okay, so for now we're gonna do test 3, which is the vertical hold. Right now I'm at my local children's park, and we have the winch, which has been unspooled inside my jacket. Why is it in my jacket? That's why. So it's going to be totally fine. This is not gonna stop me from doing the test, but well, lightning might, but let's do. Okay, so we've detached the whole entire winch from the system itself so we can actually do a good vertical test. So yeah. Okay, we're gonna use this vertical pull, which is actually, it's relatively dry in here, so I think we should be okay. One pull. Two pull. Three pull. Good, good. Okay. Just gonna hold it like this. And then we're going to release at full weight, if I can. Oh, I'm holding! I'm holding! Oh, that's so cool! It supports my weight, I swear. You gotta hold it the right way. That way. Hold it like. Yeah, it supports my weight. Awesome. Okay. That's a successful test. So there you have it. That's the ODM prototype project. So obviously there's some things I want to improve on and things I want to add on in the future. First, the winches are too slow. Obviously they just have this set gearbox that basically I can't tamper with and has this set tempo. So we need to get a different system in order to move faster, just like kind of like the show. So I'm thinking we have some e-board motors on top of a gearbox that basically moves a spool. Whether or not we'll use steel rope again, I don't know. We'll have to see. Maybe some Kevlar cord maybe next time, but maybe we'll keep with the steel cord because the steel cord worked pretty well. We just need to keep it light. So now we need to also think about power to power that system. Obviously, having it be cordless would be most ideal. So just some batteries for e-board, skateboards should do the trick, and they recharge pretty easily. So that's kind of an improvement. For CO2, I think honestly finding a way to make a custom remote valve with the servo motor that could tell us what angle we want it to do, or tell it what angle we want it to do, and also having some sort of automatic and motorized valve that releases with also enough compressed gas to really push us with more thrust while keeping it light, I think would be the next step in the CO2 improvement. Obviously, I want to add part 3 where we have the grappling hook with kind of a gun, or maybe just even making a launcher for some reason. So, that's at least for some improvements. And hopefully, with more time and a lot more money, this project will be able to move on to phase 2 and hopefully get one step closer to ODM in real life. Granted, I think this is the closest thing to ODM gear in real life because it's self-contained, it does what ODM mostly does, it's a pretty easy system, and it kind of somewhat still recreates some of the effects. So for a prototype, I'm more than happy. So thank you so much for watching this video. Please share and like this video just so more people can see this project and more people can either be inspired or just have a fun time watching. I'm not going to ask you to subscribe because obviously this channel is not going to have consistent uploads because projects take a heck of a long time and I have a life. So just please share and like this because it really means a lot to me, and it means a lot for me to see other people enjoy what I create and to be inspired by what I do. So thank you so much for watching. Have a great day.